Greetings, lovelies. Welcome back to another episode of Technically a Conversation. Here, we're sharing some interesting stories and interesting topics with one another. Hopefully, you'll find it interesting too. I am one half of the fun hosts, Isela, and joining me as always is the more fun half, Jose. How are you?
I'm doing great. How are you?
I am lovely.
That's great to hear.
Good. How was your week?
Good. Starting off the morning like I do every morning with a fresh, hot cup of coffee.
Oh, so lovely.
Hopefully, our listeners are enjoying a cup of coffee with us this Monday morning as well. And I want to take the opportunity to shout out some of our listeners, some of the people that have been the most active on social media, that have, replied to our post or have sent me text messages or, messages regarding the show.
Sliding into your DMs.
None of them have slid into my DMs, but
Just kidding. I'm kidding.
But it's just people that have been very active. So I want to shout out Elena, Erica, Rachel and Tony, Katia and Kirby, and Carlos. So thanks for listening. Hope you all are enjoying the show. And if you are enjoying the show, let your friends know. Spread the word.
I like it. Also want to shout out. I know there's one family in the UK. Shout out to the Browns. What up?
I also wanted to tease. I'm such a tease. That we'll be doing a Lucifer finale recap show. The finale drops in a couple of weeks and we're super excited about it. If you're a fan of Lucifer like we are, send us your thoughts, your reactions, whatever's on your mind to greetingstac@gmail.com or leave us a voicemail at 915-317-6669. This will be a bonus episode that you'll get in addition to the regular weekly show. So if you want to hold on to it until you've had a chance to watch the show, you can. Or if you don't care about the show, you can skip it. But if you're a fan, hopefully you can join us in the conversation.
All right. So here's my question to kick us off. Do you ever just go outside and gaze at the moon?
I do, actually.
Really? So you do this often?
Not often. I'll do it when I hear that, Jupiter's going to be visible or Saturn's going to be visible. I'll go out there with my telescope and do a little bit of amateur astronomy.
It's fun, right? Yeah.
It is.
I love the moon. I think it's so pretty. I think it's also something that we take for granted because it's always there and not everybody always looks at it. Kind of similar to our mountains. I think our mountains are so beautiful. What other city has mountains smack in the middle of the city, which sounds inconvenient, sure, but it actually is so pretty.
I have to agree. I love the mountains.
Right? They're a little bare. I know. They're a little naked. Sometimes we like naked. So, going back to the moon, a while back I heard astrophysicist Dr. Neil deGrasse Tyson. He said once that the moon was slowly drifting away from Earth. So, this concerning fun fact, wait, can you have a fun fact that's both concerning and fun?
Sure. We just did.
I know. We just did it right now. So the fact that he said that it was drifting away really kind of got me thinking well, why is it drifting away if it should be pulling closer towards us since we're bigger is kind of what I thought. And of course, this also goes to show I don't really know a whole lot, right? And then how much is it drifting away is kind of the other question it led me to. And then eventually rolled into what kind of effects is it going to have on Earth if we don't have a moon? So this, good sir and lovely listeners, is the tasty knowledge nugget that we're going to be chewing on today. I found this wonderful information on a History Channel episode, and it's called Earth Without the Moon, in case you guys want to look it up. Right? Sounds a little... Dude, it sounds like we can file that under educational and horror at the same time. Our nights would be so black. That sounds I don't know. Sounds a little scary.
It does. A little ominous.
It is, yeah.
I'm already thinking about the tides and everything, but I'll let you share that. Your fun nugget, as you say.
Yeah, the fun nugget.
Dip that into that barbecue sauce and start chewing on that fun or knowledge nugget.
The knowledge nugget, yeah. Get some A1 all over that. Right, we're taking this way too far. Okay, so let's just get this party started before we go off the deep end. So let's start off with how the moon was formed. And then we can talk about how it grew up to be our best friend, Earth's best friend. So we're going to go back in time, very Bill and Ted's Excellent Adventure style. Only it's Jose and Isela.
Should I call Barry Allen?
Should call Barry Allen. Let's get him ready.
How far back are we going?
We're going to go 4.5 billion years. Can you get us there?
Let's see. Barry, take us back 4 billion years.
Okay, just gotta go faster than the speed of light, far beyond the speed of light. You gotta break the rule, Barry, and you gotta do it now.
Boy, it always makes my stomach a little queasy doing some of that time traveling.
Well, it's about to get worse.
Oh.
Buckle up, son. So, 4.5 billion years ago, when the Earth really wasn't Earth as we know it today, so let's call it Earth 1.0. Back in that time, we had about an 8-hour day. So we were spinning pretty quickly. And it had tons of volcanic activity. So that means there was molten lava everywhere. And then also liquid iron was pretty abundant as well. And as we were spinning and gathering all this debris, which was fusing to Earth 1.0, making it bigger to the size that we know it now, all this debris was coming in from the solar system when it was so much in its infancy. And because it was really not stable back then, because, it had just formed and all these things are kind of like rolling amok, really. And this is how we would get a lot of things kind of smacking into us. And there was a lot of chaos everywhere. So 10 million years after Earth 1.0, when we started taking shape, we had a really big, violent crash with another planet. It was about the size of Mars, and it was going 25,000 miles per hour. Or 40,233.6 kilometers per hour for our 2 European listeners out there. I think the technical word for that is ludicrous speed by Spaceballs terms. So this giant impact of Earth 1.0 is what they call the giant impact theory. And it's really widely accepted by most of the scientific community.
That's a theory that I go with as well.
It sounds pretty sound, right?
Yeah.
So 70% of our molten surface was actually flung into space because of this huge collision. And it started to orbit around Earth 1.0. And that started condensing and coalescing. And that became our moon. That's already mystery solved number 1, which I think is pretty cool. How the moon formed. Scientists know this to be true, that the Earth and the moon are made of the same thing, because when astronauts went to the moon, they brought back some moon rocks. Well, they did all this analysis and they saw that the oxygen isotope ratio was identical to the one on Earth. That is basically like a fancy way of saying the ratio was exact from the water to oxygen in the rock, whereas other places would have way different amounts and ratios that would never be identical unless we came from the same place. Almost like twins with DNA.
Like Arnold and Danny DeVito.
Oh my God. You really took us back. Wow. Barry, that's enough. This debris that formed that impactor planet, it actually formed in this real specific range that was caught between both the gravity of the sun and the Earth's gravity. But the weird thing was that because it was almost like stuck, it would still do a little bit of a wobble. And the wobble was actually happening every time Jupiter came around, because of course that has huge mass. And every time it came close by in orbit, it would give this impactor planet a tiny little tug. And so the great analogy that was used in the episode was like if you were stuck in a ditch or a snowbank, the way you get your car out of a snowbank would be like you push it, you kind of start rocking it back and forth, and then it'll start going a little bit further and a little bit further, and it'll eventually break loose. So that's exactly what happened with this impactor planet. So once it got free of this position, it basically started hurtling towards Earth and it collided. Well, that's how it got absorbed into our planet's center. So the center of our planet actually has a core and a half, which was kind of interesting. And so because it's denser now, that was how our gravity actually got stronger on our surface. So this is where we kind of start to see little hints of Earth 2.0, maybe that we kind of know it today. And it was still giving off a ton of heat because of the impact. Now, all this extra iron core that's happening in our center. So the heat that was being pushed out to the crust was starting to create cracks in our mantle or fissures. They're also saying that it's possible that these cracks are what formed our plate tectonic system that actually turned our continents to what we see today.
That's very interesting. The impact theory I was familiar with, but I wasn't familiar with having the core and a half and it causing the tectonic plates.
I didn't know about the core and a half, and then it naturally made sense that we would have a stronger gravity. I guess I didn't know how far in it would be absorbed. So I don't know, that was pretty amazing. So within the year that the moon had formed, it was actually much, much closer. It was 14,000 miles away from Earth. 14,000 miles translates to 22,530.8 kilometers away.
Oh, wow. We could almost see it from here then. I'm just kidding. It's a joke.
Oh, wow. But how cool would that be? Like, can you imagine what that would look like? Because it would be so freaking close.
It would be so bright. Imagine what our nights would have looked like.
Oh my God, that's true. I didn't think about that. We would become insomniacs if we couldn't sleep, right? No, that stinks. The moon would be estimated to be 15 times bigger than what it looks like now.
Wow.
Because it was so much closer to Earth, it was causing these tidal bulges on Earth. So the way it works right now is as the moon orbits, it causes a tidal bulge that's closest to the moon. And just as a weird quirk of physics, there's an equal bulge directly on the other side of the Earth. So there's two tidal bulges. Because it was so much closer, these bulges were much bigger. And because they were so much bigger, it was creating a really big drag on our rotation. So that's actually what started slowing us down and giving us longer than 8-hour days. As Earth starts to also pull the moon in a faster orbit, and it wants to almost fling it out because now we're so big that we're like kind of dragging it around, kind of almost like in a much faster speed. What came to mind for me was that sport of the hammer throw where you made a face like, what?
Oh, yes, of course. Yeah, I play that every day.
Of course, yeah. That sport that nobody plays. It's almost like, think of like a shot put, but it's on a string and then they hold on to it and then they kind of like lean back and then they kind of like throw it out in the air to see how far they can throw it. It's almost like a discus.
Okay.
So look up the hammer throw. It's basically that same idea. And this is what Earth is really trying to do to the moon. It's really flinging it out. So there is the other weird mystery of why our moon is drifting away. And it's drifting away 1.5 inches or 3.81 centimeters away per year. So in reality, it's not a lot, but it kind of is.
Well, at least we know why it's drifting away. I thought it just didn't like us anymore.
It wanted a divorce like everybody. It's like, enough of this. You guys are treating the Earth pretty crappy and pretty soon we're going to be next. So yeah, it decided to leave us. I could see that.
After being together for 4.5 billion years, you can see why you would want their divorce. Yeah.
Best friendship has ended. So another cool analogy that they had also provided was when a figure skater does their fast spins and they go the fastest when they tuck their arms in. But then when they want to slow down, they make themselves real big. So that's kind of the same idea of how we slowed down on our rotation as we got closer or whatever, we had more space, I could say. And so it's estimated that we're adding 2 seconds to our day every 100,000 years. Not a lot.
Not a lot. I got a little excited for a moment I was like, oh, remember I was saying I wish our days were a little bit longer? We won't live to see that.
No, sadly not. And who knows how we're really going to be treating our Earth to see who actually sees that. So I think this is probably a good time for us to take a break. And then when we come back, we can continue to talk and chew on our knowledge nugget, if you will.
I'll get the barbecue sauce ready.
Get that A1 ready, baby. That Valentina. Just kidding.
After these messages, we'll be right back.
Digital Wave, Digital Wave. All your online service on Digital Wave. Find out what's got all our customers singing. We offer a comprehensive online suite to meet all your needs. 128-bit encrypted email? Check. A fast, secure web browser? Check. Database software for your business? Check. Protection from ransomware? Check. Digital Wave, Digital Wave. All your online service on Digital Wave. 1 terabyte of backup and online storage? Check. End-to-end encrypted messaging? Check. Web hosting and domain registration? Check. Malware and virus protection? Check. Day-to-day life is hard enough already. Let us take the hassle out of your online presence. We take your privacy very seriously and never sell your information to any third parties or advertisers. Sign up for a free trial and see why our customers are singing. Digital Wave, Digital Wave. All your online service on Digital Wave.
And now, back to the show.
And the little song is kind of catchy. It's got me singing Digital Wave, Digital Wave.
That was kind of jamming. I was like, ooh, that's going to be on repeat. All right. So to continue on our
Knowledge nugget.
our knowledge nugget, let's continue to chew away.
Got a bucket of barbecue sauce ready.
Of that. Ready? So gross. So if we didn't have a moon, our spin would be faster, right? So what happens when our actual rotation is faster? It means our magnetic field would also be stronger, which is crazy. So if our magnetic field was stronger, then it would actually be deflecting more of those high energy solar flare particles. That is what we see when we see the aurora borealis. That means if there would be more of those deflected, we wouldn't necessarily have to be at the North Pole to see the auroras.
Sounds like a big win to me.
It actually would be kind of cool. That is possibly the only plus to not having a moon.
Now, will the magnetic field be strong enough that it'll pull the iron out of our blood like Magneto?
I don't even think we would be alive if that would be exactly. Not that I don't want to consider that, but yeah, that would be pretty cool actually. So because Earth would be spinning faster, our jet streams would also be faster. That means stronger hurricanes, more lightning storms because of all the friction in the air particles moving more. What I was thinking of was sounds like it would be really similar to the atmosphere in Jupiter. Because you know how you have like all those hurricanes and the Great Red Spot. There's tons of lightning. And so that was kind of what I had likened that to also. Even though the moon is just a solid rock, just by first glance, it doesn't seem like it does anything for us. But oh my goodness, as we have explored what it really does, like it's really insane. They also talked about what would happen if it suddenly disappeared, almost like a light if it just turned off. So because it would suddenly disappear, it would almost be like if you have a water balloon on a string and then you snap it, then it almost would like have this like bounce on the inside. So they were talking about how it would create like all these crazy tsunami effects and giant waves would come crashing inland. And it just sounded like a mess and mayhem, which don't think I would want to live in that Earth, let's say Earth 3.0 or whatever that would be called. Some of the other things that they were contemplating, what life would be like, and because it would be so windy and chaotic, that tall things wouldn't really be able to exist. So like the palm trees would really never take shape because it would be so difficult for them to stand. And probably giraffes would also never really exist because they would never have to evolve that long neck to eat above.
But midgets like me would thrive.
This would be your heaven. I'm just kidding. No, it would be too windy. Can you imagine? With your short little legs. Just kidding. I'm just kidding. Another interesting thing that they were talking about was the pull of the tide that we see today is actually 2/3 from the moon, and 1/3 of it is from the sun. So if we never had a moon, the tides would be super, super low because it would only be 1/3 of what we see. All of the oxygenation and all that stuff that normally happens with our larger waves. I mean, I think it's pretty fascinating to think like what everything has to, all the things that have to line up in order for just like the smallest microorganisms to have started to kick off this idea of life.
Have you heard about the theory where life probably started on another planet? And it might have started when a comet collided with Earth?
I did hear about that. I need to hear more. Do you know more, or you want to make this an episode and then you can keep me in suspense?
I think that would be a good topic for another episode.
Okay, dang it. Oh, man, a lot of suspense. Okay.
I wish I could tell you more, but I don't know all that much about it. So that would give us an opportunity to do a little bit of research on that.
Okay, cool. I feel like I'm using you a little bit, but yeah, you research that and then let me know.
All right.
Let us know. So another really cool thing that the moon is responsible for is, you know how the Earth has that tilt, the like 23.5-degree tilt? It gives us our 4 seasons. The moon actually keeps that tilt steady. So if we didn't have the moon, we would have a really wacky variation of tilting. It would be very similar to Mars because Mars doesn't have a moon like we do. And Mars has an axis that tilts as low as 15 degrees and as high as 75 or 80 degrees. It's really insane. And that was another thing that they were saying, like, well, no wonder that planet is so dead. The climate is changing so rapidly. It's cold and it's icy and it's all that stuff. How could life even form? That was another thing that they were kind of theorizing what it would look like, at least on Earth. Our seasons would be completely out of whack. Ice would easily form over the Amazon. And conversely, there could be forests forming and developing in Antarctica. We wouldn't even know how long those types of seasons, if you will, would stay because we would be so unstable. And as far as humans are concerned, it would be way too difficult for humans or even life to adapt. So they even mentioned how the last time we had an ice age that humans didn't fare very well. And that was, you know, a long time ago. And some of them made it out, obviously, because we're here. But he was basically saying it'd just be really honestly way too difficult to adapt to large swings in heat to cold. We would definitely see like that. So in conclusion, our solar system has about 150 moons. Ours is pretty huge compared to the other planets, like the ratio in comparison to their planet that they orbit. Our moon is about 1/4 of the size of Earth, which I thought that is pretty big when they tell us like that.
Yeah, I didn't realize it was that big.
Right? Yeah. In reality, because it's so big, they had mentioned that we're really acting more like if we were a double planet system. In order for humans to thrive like we are right now, that's really exactly what we needed. We needed this crash to happen. We needed the weird stuff forming outside in that perfect, you know, space of like Earth and the sun. And I don't know. I keep thinking about all the things that really needed, all the stars had to align. You know, they always say that in order for humans to really thrive. So hopefully this was also like a good reflection point on how maybe we can do a whole lot more to like help save the planet. Because it went through like hell and back to be formed for us to thrive. We're definitely taking advantage of it. Maybe a little less gas, maybe save on water, save on electricity, that type of thing.
I'll stop eating as many beans so that way I have less gas.
The methane. I think you are fine. I don't even think you eat any beans, by the way.
Not that many. I do eat meat. I'm Mexican, so that's part of my diet.
It's a staple.
But yeah, usually what messes me up is dairy. Like I've told you before, I have holes in the ozone layer right above my house,
They're named after you.
especially when I eat ice cream. Forget it.
Wow. We're getting really close again. We didn't think we were going to get very personal again, but we definitely are.
It's hard not to get personal when we're talking about the moon.
It's romantical. It's like our best friend. It really does give us life.
Wasn't there like some poem that said, when you miss me, go outside and look at the moon and I'll be looking at the moon there with you, or something to that effect?
I know there's a movie that was very similar to that. The one with Kate del Castillo. I know it was in Spanish, so I don't know if it was like translated everywhere, but it was called Under the Same Moon, Bajo la Misma Luna. And it was about how this mom and son, I think they get separated somehow. Maybe she goes or he goes to America and one of them stays back, and they kind of say that, you ever want to think of me if you're missing me? Just remember I'm underneath that same moon. It was really cute.
Yeah, it sounds very sweet.
Yeah. Oh, it's a great movie, but it's quite the tearjerker. So get the Kleenex out. But it's a really great movie. I'm going to end with some parting fun facts.
Yes.
Moon related, but not just moon related. So you know how our moon has phases, right? Like it's like the full moon and then a new moon and, the waxing and the waning going on. We actually have a planet that also has phases. Only one planet does this. You probably know.
I don't actually.
Ooh.
I thought the phases was something that was unique to our planet.
Well, I know it's unique to our moon, but I know one other planet that does have it is Venus. So Venus does have phases. Pretty cool. Our moon is bigger than the planet or dwarf planet Pluto. So you got to think that planet was really tiny then.
Well, maybe if the moon disappears, we can bring Pluto over and it can be our moon.
I feel like it's been so dejected. I feel really bad for it. Yeah, I agree.
Make it feel a little bit more welcomed by bringing it into our rotation.
Come on in. Come on in. and lastly, our moon has a really tiny core, and that's why the gravity pull is not very strong. Whereas we have 1.5 cores. Yeah, we'll go with it.
Yeah, I'm not sure how you would say that. But that sounds right. 1.5 cores.
Yeah. This is the end of our knowledge nugget. How did you find it? Did you get all your questions answered? Was it anything like you had heard?
Well, I'm definitely all covered with barbecue sauce. I feel like I need to take a shower to rinse it off.
We did go a little deep. I know this one was pretty nerdy, but I also try to keep it as understandable as possible too.
It was definitely very interesting. A lot of what you covered I did not know about. I enjoyed it.
It was fun reading about it. And then every time I would learn something, I'm like typing, right? And then I'd be like, oh my God, did you know that? I'm over here like yelling to my daughter, did you know that blah, blah, blah? And then she'd be like, what? No. So it was fun.
Who was the narrator? Was it Neil deGrasse Tyson?
No, it was, I don't know. It was a man on the History Channel episode. But they had all kinds of people that they were interviewing. So it was astrophysicists and people from Berkeley. And I've seen him in some other astronomy type things. I don't remember his name anymore. Shoot. But you'll see familiar faces on there. If you like and follow astronomy, there's a lot of familiar faces. It's pretty cool.
Cool.
Yeah, I enjoyed it. Well, you've done it again, folks. You have spent a lovely 30 minutes with us or so. So we thank you for joining us on another fun conversation. If you're enjoying the podcast, subscribe, leave a review, tell a friend. And then you can follow us on Instagram and Twitter at greetingstac or email us at greetingstac@gmail.com. Also, you can leave us a voicemail at 915-317-6669 in case you have a story to share with us. Thank you so much.
And I bid you to keep looking up.
He does say something like that. We don't want to get in any heat. That was a joke. It was a parody.
Sure.